Welcome. In this video series, we're going to look at functions. So right now we're just going to define a function, and before we do that though, we need to actually talk about relations, domains, and ranges and all that good stuff. So kind of backing up here a moment, we previously looked at the Cartesian coordinate system, and so in the Cartesian coordinate system we had the ordered pair x, y. And sure, it is a coordinate on the coordinate plane, but really when we match an x and a y pair, generally in mathematics, what we're talking about is something called a relation. In a relation, you can see it's just a set of ordered pairs and some rule to connect the x value to the y value. Okay, so really the relation have to have a set and it's a rule. Okay, in that set, when we look at all the x's, that is what we call the domain of the relation, and then all possible y values are the range. Okay, and those again, those are sets, right? So we have set notation. So typically when we do sets, we have to enclose the members in braces. I call them curly brackets sometimes. Otherwise, if we have like an interval, we know interval notation, so we might have, parentheses or square brackets, something like that. Okay, so but the idea overall, again, of a relation is that you have some x values. I'll just label these as x1, x2, x3, x4, and these would be in your domain. Domain with an I, and then these are sent into a new set that looks a little different. This is going to be your range, and these are going to be your different y values. We don't exactly know which one might go to which, so for instance, y or x1 might go to y3 or something like that. Those might be matched, for instance. x3 might be sent to y2, x4 might just go to y4, etc. We don't know, okay? But that's the idea. And maybe x1 goes to two things. I don't know. Okay, so here we have just a set of ordered pairs, and as a quick example. So we want to identify the domain, the range, and then plot the ordered pairs. Okay, so the domain, again, here, since we have a discrete set, there's, finitely many things. Typically, we have to list these in set notation, so with the braces. So I'm just going to go through each of the ordered pairs and pluck off the x values. So we'd have 4, -5, -1, 6, 2, -3, 0, and 2. Okay, don't have to be in any particular order, but that's what I chose to write them in. Okay, for the range, again, these are all the y values, all the second values in the ordered pair. So this is going to be 3, 2, 1. 3 is already listed, right? So I don't need to list it again. I can, it's just redundant. -4, 4 and -4. 1 is already listed, and then -2. Okay, and again, enclosing those in braces because it is a discrete set. Okay, so now I'm going to take some time and plot the ordered pairs. Okay, so I encourage you to pause the video, do it on your own, resume the video when you're ready to see the plot. Here's my plot, and I'll maybe just zoom in a little bit so it's easier to see. So I plotted the ordered pairs, and here you go, and it says, what do you notice? Well, I don't know. There's blue dots all over the screen. That is an observation. Another observation I notice is that okay, I didn't plot these exactly. Maybe I'll plot this point a little bit better. But right at x is equal to 2, right? If I look at that vertical line, I have 2 dots along that vertical line. Foreshadow, foreshadow, foreshadow. Okay, so notice what you're going to notice. Okay, I digress. So we know about relations, set of ordered pairs. We know about domain, we know about range. When we look at relations more generally this semester, we're going to look at what we call functions. Okay, and functions, again, you've probably heard of them. It's a relation, so we have a set of ordered pairs, right, where every member of the domain, so all the x values, is assigned to exactly one member of the range, y values. Okay, so when we look at that domain and range setup, okay, so domain, I'm going to use capital D and capital R just to make this easier. And if I have a bunch of things, again, I had x1, x2, x3, x4, okay, y1, y2, y3, y4, okay. When I look at each member of the domain, they have to be sent to exactly one member of the range, okay? What cannot happen, and I'm just going to do this in purple, so this I'm going to say is a warning, okay? This would not be a function. If I did something like this, x1 went to two different things in the range, okay? And so in my example, I'm getting ahead of myself. Okay, I don't want to, I want to save that fun for later, okay? But so if we have a domain element with two range elements, that's not a function, okay? So if we omit that, then we have a function. All right, so when we have a function, we also introduce some notation saying that y is equal to f of x. This just means that we have an input x has something done to it, that's what the f means, and then whatever that something done to it is, whatever that produces, is your y value. Okay, so we have a few following functions. Okay, so here we go. The first one is what we plotted. So if we look back at that one, this one is not going to be a function because at a given x value, right, I have two y values. That can't happen for a function. So this one is going to be a big old no, okay? Next, I'm going to move to the second example. So I'm going to look at each of the domain elements. Okay, so 1, 0, -1, 0. Okay, so I want to look if I have a repeated domain element, okay, do we go to the same range element? And so I notice I go to 1 and -1. So I have a single domain element going to two different range elements. This is not going to be a function either. Can't have that happen. Okay, last example. I'm going to look at the domain elements 1, -1, 0, 2, -2. Do I have, if this were to represent a relation, do I have any repeated domain elements? No, I don't. Okay, so since I don't have a repeated domain element, I don't need to check to see if a single domain element goes to two different range elements, right? There's not a possibility of a domain element going to two different ones if there's only one domain element appearing ever. So this one is a function. Okay, so again, make sure to check your definition for domain, range, relation, and function. Function is a super important definition, and maybe just having that mental image of, checking to see if a single domain element goes to multiple range elements. If that happens, then you don't have a function.